Yeah, good evening. Welcome to this my linear algebra live session. Okay, myself Samir Mondal, a Prime Minister Research Fellow in the discipline of mathematics at IIT Madras. Today we'll try to solve the problem which assignment two which assignment is uploaded by Professor Dilip P. Patel in NPTEL websites. Okay, so Rajesh, Sattam, and Lima, did you see that problem sheets? Rajesh?
No, sir, we are not able to see any seats, sir.
Oh my God. No, means already Professor Dilip P. Patel uploaded that one assignment to problem sheet. Did you see that problem sheet or not? Yeah, my question is, did you see that problem sheet or not? Please respond. Sattam, please respond someone. Did you see that assignment sheet too or not? Please respond. Please respond someone. Did you see that problem sheet or not? Sattam? My God. So first question was given in assignment 2 was K be your field. Okay, this field may be your real number or the field of complex number. Okay, yeah. So one I am not able to share my screen. Okay, so please try to download that assignment sheet problem. Do you have assignment second assignment or not? Please respond. Do you have assignment 2 problems or not? Okay, so do you have any issue? Yeah. Do you able to see these problem sheets? Did you anybody try this one 2.1?
Yes, sir. We can see, sir.
Yeah, did you try this one? Anybody tried this problem 2.1? Please tell me what do you mean by the set k power I. Please respond, otherwise continuing this class is too difficult for me. What do you mean by k power I, this set? Please try to cooperate, otherwise continuing this class is too difficult.
It is the field of real numbers, field of complex numbers. That power is I, sir.
Now what do you mean by, yeah, this set k power I? Yeah, so basically k power I means all function from the set I to k. Okay, so k power I means all function, all functions from the set I to k. Okay, so you have to check that the subsets k power I finite equal to all such functions from ki such that f of I is finite. It is your subspace or not over the field k. Okay, please check it. Please let me know it is a subspace or not. K power I finite means all such functions from ki such that f of I is finite. Yeah, please someone responds. Rajesh, please let me know what is the subspace of a vector space. What is the criteria?
That is also a vector space, sir.
Yeah, over the field,
Sir,
over the which field, same field or not?
same field, sir.
Yeah, so what is the criteria for that?
Sub vector space.
Yeah, so checking vector space is too lengthy, na? So if we check that, we will take some element from two element from arbitrary two element from your field set and arbitrary two element from the that subset. So we'll check, suppose alpha and beta two element from the field and x and y two element from the subsets. Okay, then we'll check alpha into x plus beta into y belongs to that set or not. It is if you if this element belongs to the that set, then we can say that this is a subspace of the vector space, the given vector space. Okay, am I correct?
Yes, yes, sir. Correct, sir.
Yeah, please check this one. First one, a, the subsets k power I finite defined by this way that all functions from I to k, okay, such that f of I is finite. Check this says these subsets subspace or not.
subspace, sir.
Yeah. Okay. Then for second one, k power I is countable. This one. Please tell me what do you mean by a set is countable.
A set is countable whether we have to give which one is the first element and which is the second element. We can count the numbers. Therefore, the particular set is called countable. Am I correct, sir?
Can you explain mathematically? Your
Sir,
your intuition
Uh,
is correct. So please.
the set, sir, set of all natural numbers, set of all rational numbers, set of all integers. Rational numbers, we can say, suppose we are taking the set of all integers 0, plus or minus 1, plus or minus 2, etc. We can say that 0 is the first number, 1 is the second number, minus 1 is the third number. 2 is the fourth number, minus 2 is the fifth number. In this way, we can arrange all the numbers. Therefore, the set of all integers, rational numbers, and then natural numbers are countable, but the real numbers is uncountable because it includes both rational and irrational.
Yeah. Now my question: what is the exact
hello.
definition of? Yeah. Please tell.
Yes, sir.
Hmm.
Sir, any set which is either finite or we can create a mapping that set map to natural number.
Any map or
You
some
can,
particular map?
uh, I think bijective map, sir.
Yeah, bijective map. So a set is said to be countable if there is a bijective map from that set to natural number. Okay.
Yes, sir. Yes, sir.
Yes.
Yeah. So check that one is subspace or not.
Subspace, sir.
Okay. And third one, a function is. What do you mean by a function is bounded? Please, someone try to give the answer.
So if the range of that set is bounded to, so we can set that set is bounded.
Yeah. So modulus of f of, suppose your this is your real number or complex number k. Okay, field. Okay, then one function f from the your domain at I to k is said to be bounded if modulus of f of x is less equal to m. This m is any, there exists a particular real number. Okay, a function f is said to be bounded if there exists a real number m such that modulus of f of x less equal to m for all x belongs to your domain set I. Then we can say f is bounded. So you have to check that k power I, this subset is a subspace of the vector space k power I. Okay, please let me know this subset, this is a subspace or not.
Yes, sir. Subspace, sir.
Okay, so I have one question. So already I told about what do mean by k power I. Okay, here replace k by a. A is your finite set. Take the cardinality of that set is n, and take I. Suppose any subset, finite subset, finite set b of cardinality of b equal to n. Okay, yeah, replace your k by a, cardinality of a equal to n, and I replace by b, cardinality of b equal to m. Then please tell me what do you mean by a power b. Yeah, please tell me what do you mean by At first tell me what do you mean by k power I? What is the notion of this set k power I? Before starting this problem I told na. Please try to give the answer. Yeah, please, Rajesh, tell. What do you mean by k power I?
K1, comma K2, comma etc. up to, sir.
No, k power I means set of all function, okay, from the domain I to codomain k. Understood or not?
Yes, sir. Understood, sir.
Yeah. So now replace k by a. A your finite sets. Cardinality of a equal to n, and replace I by b. Cardinality of b equal to m. Please write down in your copy. Today I am not able to share my screen. Yeah, iPad screen. This is the issue. Okay. Please replace k by your finite set a and I by finite set b. Cardinality of a equal to n and cardinality of b equal to m. Okay. Understood or not? I am not. Please let me know.
Yes, sir.
Yeah. Then what do you mean by this set a power b? Hmm? I am talking about
Sir, excuse me, sir. Please repeat me, sir. Kindly repeat me. What is K power I?
k power I means set of all function whose domain is I and codomain is k, means set of all function from the set I to k. Okay.
Okay, sir. Okay.
Then what do you mean by a power b? Where? Yeah, please let me know. What do you mean by set a power b?
Set of all functions from B to A.
Yeah. So please let me know if cardinality of a equal to n and cardinality of b equal to m, then what is the cardinality of a power b? Or please let me tell me how many functions are there from the set b to a. Suppose your cardinality of a equal to n, okay, and cardinality of b equal to m, okay.
N power M.
Then a power b your all function from b to a, then find the cardinality of a power b. Yeah, what is your answer? What is your answer? Please tell me, Lima.
Sir, N power M, sir. Is it correct, sir?
N power m. How? How?
Because cardinality of A is equal to N and cardinality of B equal to M. Therefore, A power B means N power M.
Yeah, this mean all function you have to find all function from b to a, where cardinality of b is m and cardinality of a is n. So how you'll find all functions? So choose your function domain is B, codomain is A, and how many elements are there in B? Total m number element are there in B.
M number of elements
Yeah.
in B
And
and N number of elements in
in
A.
A. So choose one point from B. Okay. So how many choice have these elements? Take one element from B. So this map F. Okay. So under this map, how many choice have this element in A? In your code
And
domain,
choice, sir.
yeah,
N
n choice.
number of elements.
N choice are there na? In your codomain total n number element are there. So if you choose one element from B, so these elements have total n number of choice. Any of this element, this element can map that element, okay, by under the map F. Okay, so for every element of B, there are n number of choices there. Okay, so total number of choices n power m. Okay, understood or not?
Okay, sir. Yes, sir.
Yeah, so quaternity of A power B equal to
N
n
power
power
N.
n. Okay. Okay.
Okay, sir.
Yeah. So try
Sir,
to
the answer is n power m. I
Sorry?
can't get your voice clearly, sir.
sorry
N power m. Is it correct, sir?
n power m. Yeah, it is correct. N power m.
Okay, sir. Thank you, sir.
Yeah. Please try to solve the problem B. At first, let me what do you mean by even function?
A function f of x to be even if f of minus x is equal to f of x, sir.
F of x equal to f of minus x. Okay, fine. And odd function?
F of x is equal to minus f of minus x, sir.
Okay. So try to check this one, that set of all even function is a subspace of set of all functions. Okay. Here your set of all function form a vector space over the field R. Okay. Sorry, over the field K. K means any K, either K means field of real number or field of complex number. Okay. So at first take the collection of all function from real number to K. This will form a vector space. Okay. And set of all even functions is just definitely subset of set of all functions. So you have to prove that set of all even function form a subspace of set of all functions over the field K. Okay.
Okay, sir.
Yeah. So what is your answer? It will form a subspace or not?
It will form a subspace.
Okay. How you will prove this statement? Yeah, here your vector space is K power R. Okay. And collection of all even functions is denoted by W in suffix even. Okay. So this is definitely subset of K power R. So you have to prove that this is a subspace of K power R. So take two arbitrary function f and g. Okay, belongs to W even. Okay, your f and g both are even functions. Okay, and take two scalar alpha beta from the field K. Then you have to prove that alpha into f plus beta into g is a even function. Am I correct?
Yes, sir.
So your f is an even function, your g is also even function. Okay, we have to prove that alpha into f plus beta into g is an even function. Means you have to prove alpha into f plus beta into g acting on x. Okay, then what we will get? We will get alpha into f of x plus beta into g of x. Since your f and g both are even function, we will get alpha into f of minus x plus beta into g of minus x. Okay, then we will get alpha into f plus beta into g in acting on minus x. Did you understand or not?
Yes, sir. Understand.
Yeah. So similarly, we can prove that set of all odd function form a subspace of the vector space k power r. Okay, under the same field k. Is it fine? Please respond.
Yes, sir.
Yeah. So next you have to check that 0 is the only even function as well as odd function. There are no such function such that that function is even as well as odd. Okay, so you have to prove this one, that set of all even function intersection set of all odd function is the null set, means only 0 element are there. Try to prove this one.
Yes, sir. Yes, sir.
Yeah. What you have to prove? Please tell me. You have to prove that set of all even function. Okay, set of all even function intersection set of all odd functions equal to, will get only the 0 functions. Okay, suppose let a belongs to w even intersection w odd. W even means even function as well as f is an odd function. Okay, please respond.
Okay, sir.
Okay, sir.
Yeah, so your even function means f of x equal to f of minus x. Okay, and as well as f is an odd function, then we will get f of x equal to minus of f of x. So please combine these two statements. Your f is a even function means f of x equal to f of minus x, as well as f is your odd function means f of x equal to minus of f of minus x. Then we will get what? We will get f of x equal to f of minus x. Okay, and since f is an odd function, we will get f of minus x equal to minus of f of x. Am I correct?
Yes, sir.
Yeah, so from here we will get 2 into f of x equal to 0. Did you get this statement?
Yes, sir.
Yeah, from here we will get f of x equal to 0 for all x belongs to your domain R. Okay.
Okay, sir.
Yeah, so we are getting f is a 0 function. Okay.
Okay, sir.
Yeah.
Yes,
So
sir.
yeah, the set of all even function intersection set of all odd function we are getting, there are only 0 function is there. So intersection is null. Okay.
Okay,
Okay,
sir.
sir.
Okay. So next try that set of all even function w even direct sum set of all function will get all functions from set of real number to k, means k power r, we will get this one. Yeah, try to prove this one. Yeah, this statement w even direct sum w odd equal to k power r, you have to prove. Okay. One side is obvious, means we already know na, set of all even function is a subset of k power r. Okay. And as well as set of all odd function is a subset of k power r. Okay.
Okay, sir.
Yeah. So we know since the intersection is 0, so sum of two vector space is will form a again form a vector space. So we will get set of all even function direct sum or sum set of all odd function will form a subspace of k power r. So automatically we are getting w even plus w odd subset of k power r. You have to prove another way, means you have to prove k power r is a subset of w even plus w odd. Is it okay?
Yes, sir.
Which part is obvious? Please tell me. Please.
W1 plus W odd is a subset of K power R. Is obvious.
Yeah, you have to prove another way. Means
Yes.
k power r is a subset of w
Subset
even
of
plus
W1 plus
w odd.
W odd.
So you have to take one arbitrary function from k power r. Take f is a arbitrary function, arbitrary element from k power r. Okay. So you have to write f is a part of even function plus part of odd function. This is your aim. Okay. So how we can write one function is a sum of even function and sum of odd functions. This is your aim. Okay. Yeah, try to
Okay, sir.
try to write f is a sum of even function plus sum of odd function. Then we done. Okay. So how we can write? Please try to understand that f of x we can write f of x plus f of minus x, okay, by 2 plus f of x minus f of minus x by 2. We can write f of x equal to f of x plus f of minus x by 2, okay, plus f of x minus f of minus x by 2. Did you understand or not?
Yes, sir. Understood.
Yeah. So calculating we will get f of x. Okay. So you can observe the first term f of x plus f of minus x by 2. This is a even function. Am I correct? Am I correct or not? Please tell me. F of x plus f of minus x by 2, this is a even function or not? Please tell me, is it correct that f of x plus f of minus x
Yes,
by
sir.
2?
Even functions.
Yeah,
Correct,
and
sir.
check that f of x minus f of minus x by 2. This is odd function. Please check it. Did you check it that f of x minus f of minus x by 2 is a odd function?
Yes, sir.
Yeah. So we can write one function as a sum of even function and sum of odd functions. So yeah, your k power r is a subset of set of even function w even plus set of odd function. So we are getting, yeah, w even plus w odd equal to k power r. Is it fine?
Yes, sir.
Yeah. So please try to check, see in your home, okay, because the time is very limited. uh, so I think if we go 2.4 it will be better. I think this inequality you can try it in your home, okay, or if you
Okay,
want to
sir.
try it here, I have no issue. we can we can try here, or after 2.4 we will go 2.3, okay. 2.4 is little bit interesting.
Sir, can you teach me 2.2, sir?
No, this is your assignment problem, so I can't solve. This is not good, I think. If you have any doubt, I can explain. Otherwise, I can't give you the solution. This is your assignment problem, na? This one you have to submit this problem. If you have any doubt regarding this question, you can ask me right now. No issue. But I can tell you the solution for this one.
Sir, that n denotes dimension, sir. N denotes.
No, in your here 1 minute, vector space over a field K. Yeah, dimension, not a cardinality. Here, your n is a dimension here. Okay.
Okay, sir.
Yeah, try to check 2.4. This is a one interesting question. So at first you have to understand what do mean by this map epsilon a. Okay. Before that, please tell me what is the polynomial. Okay. Polynomial over a field, take real number or complex number, whatever. Please let me know what is the definition of polynomials with the coefficient in real number.
A function f of x is said to be polynomial if f of x is equal to a naught plus a1x plus a2x squared plus etc. an x power n. That an should not be equal to 0. A naught, a1, etc. up to an are constant.
if they tell polynomial with coefficient in R, then a0 a1 up to an, this is belongs to real number. If they tells that this is a polynomial with coefficient in complex number, then this a0 a1 up to n you will belongs to C. Okay, yeah, your definition is correct. This is one type of expression, f of x equal to a0 plus a1x up to an x power n, where your a is non-zero and all coefficient belongs to the field K. Okay, then we will say that this expression is a polynomial with coefficient in K. Okay, set of all polynomial with coefficient in K is denoted by Kx. Okay,
Okay, sir.
yeah, this will form a vector space. Okay, so please tell me, take all the collections of polynomial, okay, degree up to n, okay, and coefficient is belongs to your set of real numbers, okay, and consider the field R. So this will form a vector space or not? You are taking set of all polynomials, coefficients are from the real number, and degree of the polynomial is at most n, means 0 degree polynomial, 1 degree polynomial, 2 degree polynomial, up to n degree polynomial, all polynomial are there. This will form a vector space or not? Did you understand my question? Set of all polynomials, degree up to n, coefficients is from real number, and your field is also real number. This will form a vector space or not?
Sir, it forms a vector space.
Okay, if we fixed one degree, suppose collection of all polynomials with the degree is exactly 3, okay, that time this will form a vector space or not?
Could you repeat?
If we fix the degree n, or take a degree n equal to 3, so my question is, I am collecting, or we are collecting all polynomials with the degree exactly 3, okay, over the field real number, complex number, whatever. This will form a vector space or not? Did you understand my question? Previously I was telling that take the collection of all polynomials degree up to n, means 0 degree polynomials was there, 2 degree, 1 degree, up to n degree polynomials was there. Right now I am fixing that degree of polynomial, and we are collecting all polynomials exactly the degree is 3.
No, sir.
Why?
Sir, if we add two polynomial with one has negative, so it will less that degree 3.
Yeah, so if we are taking that x power 3 is one polynomial, okay,
Yes,
and
sir.
minus x power 3 is also another polynomial. If we add, we will get 0. So 0 is polynomial of degree 0. It is not degree of 0 is not a 3. So sum of these two polynomials are not belong to that set. So it is not a vector space. So for form a vector space, we have to take that set of all polynomials up to that degree. If you want to consider the vector space of all polynomials up to 3, that time this will form a vector space, okay, and if we take exactly 3 degree polynomial, it will not form a vector space. Okay, did you understand my point now?
Yes, sir. Understood.
Yeah. Here your kx denotes set of all polynomials. Here they did not mention about degree. Means all polynomials means all degree polynomial are there. Okay, no issue. So try to understand the sets. The mapping. Your mapping epsilon a. Here a is of any fixed number. Okay, from your the field k. At first fixed one number a. Right now we are try to understand what is the mapping. Your mapping epsilon a from kx means set of all polynomial, okay, with coefficient in x, to k power k means set of all function from the set k to k. Okay,
Okay, sir.
yeah. So kx, member of kx is all polynomials. Okay, so epsilon a, take one polynomial from kx. Suppose f of x we are taking, or take f of x, okay, one polynomial. So our functions epsilon a will act on f of x, then this member will goes to k power k. Okay, please try to understand these things. Epsilon a will act on one member, suppose take f of x, a polynomial. Okay, then epsilon a will act on f of x, and this member will belongs to your k power k. K power k means set of all functions from the domain set k to codomain set k. So we are getting epsilon a f of x is a map from k to k. Do you understand these things or not? Please tell me.
Sir, could you please repeat last statement?
Okay, I am writing in my copy, then I will show you. Okay, 1 minute.
Okay, sir.
Yeah, your epsilon a is a map from kx to k power k, where k power k is a set of all function from k to k. Okay, take one arbitrary element from kx. Suppose I am taking f of x from kx. Okay, then your epsilon a will act on f of x, then this member will belongs to k power k. Okay, and your k power k means function from k to k. Ultimately we are getting epsilon a f of x is a function from k to k. Okay, yeah. So okay, yeah, I am yeah. Did you see my page?
No, sir.
Huh?
No. Sir,
It's not visible. Oh my god.
not visible, sir.
Right now?
Sir, it's visible but not clear.
Oh my god. Today my iPad is not working. I don't. So try to write in your copy. I am telling. Okay?
Okay, sir.
Yeah. So your epsilon a is a map from kx to k power k. Write this line. Okay?
Okay, sir.
Yeah. So take one arbitrary polynomial from kx. Take any take f of x from kx.
Okay.
Yeah. So your epsilon a will act on f of x. Then this member, the codomain of this map is k power k. Then epsilon a f of x will belongs to k power k. Am I correct or not?
Could you again repeat, sir, please?
But I am sharing that page. One more. This one. Yeah, could you this is visible?
Yes, sir.
Yeah. So epsilon a acting on f of x, this member will belongs to k power k.
Yes, sir.
Okay. And
Yes,
your
sir.
k power k is a nothing but a function from k to k. So your
K to K.
epsilon a f of x is a function from k to k. Is it correct or not? Please tell me.
Yes, sir. Yes, sir.
Yeah. So and so what will be the image of epsilon a f of x?
Sir,
F of a. No?
it's a f of,
You will get f of a. Means
yes.
f of x maps to f of a. Okay.
Okay, sir.
If you take g of x, the g of x will map by epsilon a equal to g of a. This is a evaluation map. We called it as a evaluation map. Evaluation at a point a. Here your a point is fixed. If we choose another polynomial h of x or g of x, then image of epsilon g image of g of x under epsilon a, we will get g of a.
A, sure.
Yeah. So right now try to prove that epsilon a is injective if and only if k is not finite. Yeah, try to prove this one. Let us assume that epsilon a is injective. So what you have to prove that k is not finite. Before that, give me a answer of one questions. Okay. Suppose you have a map f from a set A to B. Okay. You have a map from a set A to B given that f is injective. Okay. And also given that a is finite. Then what can you say that f of a? Did you understand my question?
Yes, sir.
One function given that f is injective from a domain A to B and a is also finite, then what we can say about f of b? F of a. F of is a subset of b, na? So what we can say about f
Sir.
of a? This is finite or not? Please tell me. Injective, na? So if we take two distinct element from a, we will get two distinct image of
Image. Yes, sir.
So here a is finite. Okay. So image of a, what we will get? This is also finite, na?
Yes,
Because
sir.
your f is injective map.
Sir, f is injective map and sir, B is the superset of range set.
Yeah, definitely.
So it's meant B is larger than FA. FA.
Yeah, definitely.
So,
It might be, na, larger than.
yes, sir.
So that time f of a must be finite. Okay. If your domain set is finite and f is injective, then range of that set must be finite.
Range set is finite, sir. Okay.
Yeah, range set, not b.
Okay, okay. Yes, sir.
Yeah,
Range set is
B,
finite.
B may be anything.
Yes,
So
sir.
here we have to prove that epsilon is injective if and only if your k is not finite. Okay. Okay, try to prove this one. Your for epsilon a your domain is this one, kx. Okay. Given that epsilon a is injective, so you have to prove k is finite. Please try to find and try to observe that image. What is the range set for epsilon a? What is the cardinality? It is finite or infinite? What is the cardinality of epsilon a? Sorry, what is the cardinality of the range of uh, this set kx under the map epsilon a? Try to find this one. What is the cardinality of range set of that map epsilon a?
Sir, it's equal to cardinality of A.
Your a is fixed. Okay. So for we can't say exactly k, but mm, only please let me please tell me it is finite or infinite.
Sir, if our domain is finite, then its range also finite.
Yeah, so my question is
So,
what is k of x? K of x is finite or infinite?
sir, it's set of all polynomial up to degree n.
They did not say about up to degree n. All polynomials with coefficient in k. Then what is the
Sir,
cardinality of
all
kx?
polynomial,
Yeah, finite or
all
infinite?
poly,
All polynomial na coefficient from k. So definitely this is a infinite set k of x.
infinite set. Yes, sir.
Yeah. So and given that epsilon a is also injective, so what we will get? The image of that set also
In,
infinite. Is it correct or
yes,
not?
sir. Image. Yeah, yeah, yes, sir.
Yeah.
The range set is not finite, sir.
Yeah. Image is also your infinite set.
Infinite, sir.
Yeah. So what is our aim? We are assuming epsilon is injective. We'll prove that k is not finite. Okay. Till now we are
Yes, sir.
getting that cardinality of image set is not finite.
Yes, sir.
Okay. So
Yes, sir.
suppose your k is finite. Then what will be the cardinality of k power k?
Sir, it's finite.
Yeah, finite. So how you are getting image set is infinite, and if we assume k is finite, then we are getting k power k is finite. So
Finite.
is it possible?
No, sir.
No, not possible because we are getting that image set is infinite, but
Yes,
domain
sir.
is codomain
And
is
we have
finite.
injective map.
Yeah, can be injective map.
Yes.
So yeah, converts part also you can prove in such a way. Okay.
Okay, sir.
Yeah, so please try all this problem. Okay, if you have any problem you can mail me. Previously I gave me my mail ID, I think. Yeah, today I plan to solve all those problem, but my iPad is not working. This is the issue. Right, something is going wrong. Okay, Rajesh.
Okay, sir.
Yeah, if you have any problem you can mail me. Okay, Satyam.
Okay.
Okay, we
So,
can
sir,
start.
can you provide me your email ID?
Yeah, in chat box I am telling you. Yeah, please.
Got it, sir.
Yeah, thank you. Okay,
Thank you, sir. Thank you very much.
bye bye.
Okay.